Good day everyone. Our lesson for today is about antiderivatives. And let us solve for the derivatives of the given and solve it in a step-by-step process. In solving for the derivatives of the given, the integral of x to the power of n dx, its integral is x to the n power plus 1 over n plus 1 plus c using the power rule. In this example, we must have add 1 to the power, and it will become x n plus 1, and our denominator is n plus 1 plus c. And that's how you find the derivatives of our first given. X for dx, find the antiderivatives, and the process is using the power rule. You just have add 1 to the power, so it became the variable x to the fourth power plus 1 over 4 plus 1 plus c, and our final answer is x to the fifth power over 5 plus c, and that is the derivatives of x to the fourth power dx. In our second example is 6 to the 7th power dx. Find the antiderivatives, and using the power rule again, we just have add 1 to the exponent, so it will become 7x to the 7 plus 1 over x plus 1 plus c, and our final answer is x to the 8th power over 8 plus c. And third given is 6 to the 9th power dx. Find the antiderivatives. Step-by-step process again using the power rule. You just have add 1 to the power, and it will become 6 times x to the 9th power plus 1 over 9 plus 1 plus c. And our final answer is 3x to the 10th power over 5 plus c. It is because 6 to the 10th power over 10 plus c can be reduced into 3x to the 10th power over 5 plus c. In our fourth given is 8x cubed dx. Step-by-step process is according to the power rule, and finding the antiderivatives is we just have add 1 to the uh, power of our variable, then it will become 8x 3 plus 1 over 3 plus 1 plus the constant c, and our final answer is 2x to the fourth power plus c. It is because from here to here, 8x to the fourth power over 4 plus c can be reduced into 2x to the fourth power plus c, and that's our final answer. Integration and antiderivatives. First example, the integral of 8x to the third power dx. Find the antiderivatives. Step-by-step process. We just have to put the 8 into the left side of our given, and it will become 8 the integral of x to the third power dx, and the next step is you just have to multiply 8 times 8 x plus 3 plus 1. Using the power rule of finding the antiderivatives is adding 1 to the exponent, and it will become 8 times x 3 plus 1 over 3 plus 1 plus the constancy. And our next is it will become 8 times x to the fourth power over 4 plus c, and it is reducible to our final answer. Our final answer is 2x to the fourth power plus c, and that is the antiderivatives of the integral of 8x cubed dx. Next is finding the antiderivatives of a binomial. Our given is the integral of 7x minus 6 dx. Step-by-step process is we have to separately integrate the following. Now, it will become the integral of 7x dx minus the integral of 6 dx, and it will become 7x squared over 2 minus 6x plus c. It is because of the power rule in finding the antiderivatives that we just have add 1 to the exponent, and since the exponent is 1, we just have add 1. As you see, the exponent of x is became 2, and also our denominator is 2, and just copy 6x and add the constancy, and our final answer is 7x squared over 2 minus 6x plus c, and that's our final answer. Now let's get finding the antiderivatives of a trinomial. The given is the integral of 6x squared plus 4x minus 7 dx. First step-by-step process of finding the antiderivatives of trinomial is you just have to integrate the following the trinomial one by one. So it will become the integral of 6x squared dx plus the integral of 4x dx minus the integral of 7 dx. And we just have to simplify. It will become 6x cubed over 3. It is because using the power rule, we just have add 1 to the exponent, and the exponent is x squared. Now it will become x cubed. So 6x cubed over 3 plus 4x squared over 2 minus 7x plus the constancy. As you can see, the 6 and 3 is reducible, and the 4 and 2 is reducible. That's why we reduce it to 2x cubed plus 2x squared, copy the minus 7x plus copy the constancy, and our final answer is 2x cubed plus 2x squared minus 7x plus c. Now let's continue. Let's find the antiderivatives of the infinite integral using the basic integration rules. Our first example is find the antiderivatives of the integral of x squared minus 5x plus 6 dx. Step by step process again. You just have to integrate the trinomial one by one. So it will become the integral of x squared dx minus the integral of 5x dx plus 6 dx. Using the power rule, we just have add 1 to the exponent and will become x. From x squared, it will become x cubed over 3 minus 5x squared over 2 plus 6x plus the constancy. Now simplify. Our final answer is x cubed over 3 minus 5x squared over 2 plus 6x plus the constancy, and that's the final answer and the antiderivatives of our given integral of x squared minus 5x plus c, 5x plus 6 dx. Our second example is the given is the integral of 4x cubed plus 8x squared minus 9 dx. Find the antiderivatives. Again, in finding the antiderivatives, we just have to integrate the trinomial one by one. So it will become 4x cubed dx plus the integral of 8x squared dx minus the integral of 9 dx. Now using the power rule, we just have add 1 to the exponent from x cubed into x to the fourth power, and it will become 4x to the fourth power over 4 plus 8x cubed over 3 and minus 9x plus the constant c. As you can see from x, 4x to the fourth power over 4 can be reduced into x to the fourth power, and 8x cubed over 3, it would be remain still minus 9x plus the constant c. And our final answer is x to the fourth power plus 8x cubed over 3 minus 9x plus c. Finding the antiderivatives of the basic integration problem. Our first example is finding the derivatives of the integral x cubed dx. Step-by-step process is we just have, according to the power rule, in finding the antiderivatives of this given problem, we just have to add 1 to the power from x cubed, it will become 3x, and we just have to add 1, and it will become x 3 plus 1 over 3 plus 1 plus the constant c, and our final answer is x to the fourth power over 4 plus c. The second given example is the integral of 10x to the fourth power dx. According to the power rule again, first step is we just bring the 10 the left side of the integration, and it will become 10 to the to the integral of x4 dx, and it will become, according to power rule again, we just have to add 1 to the uh, exponent, then it will become 10 times x 4 plus 1 over 4 plus 1 plus c, and we just have to simplify it, and the simplified form is 10 times x to the fifth power over 5. It is because we had exponent 4 plus 1 and also our denominator, and it will become x 10 times x to the fifth power over 5 plus the constant c, and our final answer is 2x to the fifth power plus c. And for our last example is our given is the integral of 1 over x squared dx. First things first, we just have to simplify the 1 over x squared, and it's the same as the integral of x to the negative 2, or the negative 2 power x to the negative 2 dx. And the next step is, according to the power rule, we just have add 1 to the exponent, and it will become x squared negative plus 1, and the denominator is negative 2 plus 1, and our constancy. Then simplify the exponent. So negative 2 plus 1, it will become negative 1, and also the denominator, it will become negative 1 plus c. And our final answer is negative 1 over x plus c.